All right, well, well, welcome everyone. Thank you for attending the webinar this afternoon. Today, we will be going over how using 3DEXPERIENCE structural package would help you in the next step you take in your FEA analysis journey. My name is Nick Pusateri. I reside, I'm a senior specialist in simulation here at GoEngineer, and I reside out of the St. Louis, Missouri office location. As you can see here on the screen, this is a little fun facts about me. I actually was a mechanic in past career. Of course, I like to do the weight training. I like to shoot compound bow for archery shooting. And my one and only kid just turned 1 recently. So those are some fun facts about me. And of course, at the bottom right of the screen is my email address. I will show that at the very end. If you want to send me questions outside of the webinar today, feel free to email me any technical questions that you have also. So our agenda today is first to cover a bit of what is 3DEXPERIENCE Works and what does it mean to you. Then we're going to take a first look by doing a static analysis with a design change. So we'll see the interface and how it works from there. So let's start with 3DEXPERIENCE Works. What is this? So for a long time, SOLIDWORKS has been a dominating modeling program with a built-in CFD, FEA, and injection mold package, which are very good engineering design tools. On the same side of things, there were other systems of software under the Dassault umbrella, meaning things like Innovia, Simulia, CATIA, and Delmia. Now, these programs are very powerful, and Simulia makes use of the ABAQUS solver with these. But there was always this gap to bridge the products together. So in the middle ground is where 3DEXPERIENCE platform comes into play. So the 3DEXPERIENCE platform takes the SOLIDWORKS software and bridges together the other Dassault products. So that is where it all kind of comes from. Now, when using the 3DEXPERIENCE platform, you are on the cloud. So why the cloud? Well, it's easy to install or deploy, so no IT management is really needed. Each company is given their own secure tenant that is only accessible by your company. And then Dassault gives that company access only, of course, but those outside the tenant cannot get in and see your data. It works 24/7, of course, with an internet connection. Then you have low cost of ownership, decreasing a company's overhead of software cost and analysis time on a machine. And then fast delivery, meaning that you can download and update anywhere on any PC. So that was a bit about what is 3DEXPERIENCE and its value to you. Now let's take a first-hand look on how this is all done. So we're going to be focusing on the Resman mining bolter, or really just a very specific portion of it. So this goes through the workflow of going from SOLIDWORKS modeling on your desktop and then taking it out to the 3DEXPERIENCE platform. Then validating the design and having to make a design change. So let's start with unique values here. The key thing to know here is the majority of the users have on-premise SOLIDWORKS, meaning you use it on your local desktop with a network license or as a standalone license. With Simulia 3DEXPERIENCE, it is on the cloud. However, these products do work together or do a handshake between the two. So if you make a change in SOLIDWORKS, it will be updated on the 3DEXPERIENCE platform as well. So there is no importing a model, setting it up, and then re-importing it again. Next, let's move into design management. The first step is to save the SOLIDWORKS CAD geometry to 3DEXPERIENCE platform. There is no import or export of CAD data required at this step, or should I say, and this step also ensures that once the geometry is uploaded to the 3DEXPERIENCE cloud, it can be accessed by team members from anywhere at any time on any machine where SOLIDWORKS and Simulia apps are installed. Once the files are uploaded, we will open the geometry in the Simulia app and start the simulation setup process. So let's take a look. On the boom arm here, there is a weight load and bolts connecting this mount to the larger assembly with a preload. Pistons provide a second connection point for the load. So we have a cantilevered beam with complex contacts being set up here. So we need to simplify parts out of the base here that we really don't need for the analysis, or we're going to replace them with other things to mimic them. And of course, since the part is symmetrical, we can take advantage of using symmetry for calculation speed. And we can prepare the CAD geometry for simulation completely in SOLIDWORKS, or the analyst can prepare it on the 3DEXPERIENCE platform. We'll perform some of the preparation in 3DEXPERIENCE to preserve the original CAD data. So here's the main mount of the boom arm assembly in SOLIDWORKS. So what we're going to use is the collaborative designer for SOLIDWORKS role to upload this assembly to the cloud for validation using 3DEXPERIENCE simulation tools. So built right into SOLIDWORKS on the right-hand side here is where you can launch our 3DEXPERIENCE apps. So 3DEXPERIENCE is CAD agnostic, meaning that it has CAD connectors for all major 3D modeling programs, including SOLIDWORKS, and supports for other neutral file formats. After 3DEXPERIENCE applications is launched, we are greeted by our SOLIDWORKS model, now converted to a format usable by the platform. No parametrics are carried out with it, but we can use derived abstraction shapes to make necessary edits for simulation while preserving the original CAD data for manufacturing. So the benefit of the abstraction shape is that it will maintain a link to the original geometry. So if we make a change in the design on the SOLIDWORKS end of things, it will propagate to the 3DEXPERIENCE platform. Once the shape is created, we can cut the model in half and take advantage of symmetry, of course, to save on, of course, computation time. So we're cutting the model in half. Additionally, we can partition sub-regions of the CAD model to allow for easier meshing with hexahedra elements later on. It's a quick and easy to use familiar modeling techniques to split the model up as much as you wish, and then simplifying the model and allowing for more robust meshing techniques will save a lot of time down the road. Let's next move on to design validation. In simulation modeling, we will see how to build the finite element model with meshing and connections. In scenario creation, we will create simulation steps, contexts, loads, and outputs. In results, we will see how to create customized history plots, engineering rules, and checks capturing industry-specific know-how. So here we can see our fully partitioned model. Launching the structural model creation app from the compass allows us to choose which parts from our assembly should or should not take place in our analysis. So we'll select our abstraction shape and the components from the knuckle subassembly, and then we can move on to meshing. So in the FEA world, hexahedra elements are considered better than tetrahedrons, giving similar element densities. So we'll use the partition hex mesh. We get great, real-time feedback on the viability of the shapes for hex meshing. Green and yellow volumes can be hex meshed, but reds cannot. We can even dictate how non-hex volumes will be meshed and connections will be made automatically. Meshing each part in turn is easy, or you can create meshing rules to automate meshing for future projects. Now that meshing is completed, we can begin to assign materials with the material palette. So we'll filter through the list and find AISI 304. And it's as easy as a drag and drop to assign the material to the assembly. 3DEXPERIENCE simulation offers a wide variety of material models and options. Furthermore, the material library is shared between all domains. So fluid simulation, electromagnetics, plastic injection molding, and others all call to the same library. So no more of this duplicating material definitions between programs. So with the mesh and the materials assigned, we can start creating the connectors. We're not directly modeling the boom that's attached to this bracket, but we can account for the boom load by assigning a point in space and connecting it to the model with advanced connector tools. So couplings are a powerful way of tying faces to a single or singular control node. And you can turn off individual degrees of freedom to allow translation or rotation of the control node. Then we can assign connector elements between our couplings and the reference point in space. The connector elements allow for all sorts of joints and can even be modeled with elasticity and failure parameters. So once the connectors representing the boom are accounted for, we can begin assigning bolt connectors. The bolt tool in the 3DEXPERIENCE platform here is very robust. It allows for connections of parts to a fixed ground, as we are doing here, or we can bolt individual parts together. So the bolts can be rigid or deformable and can even account for preload. The best part is once a bolt has been created, the replicate bolts tool will make a copy of that bolt in similar hole locations. So big time saver there. So to summarize, in structural model creation, we assign materials with the material library. It contains a wide variety of material models and serves as a one-stop repository of material information for all simulation domains. Next, we assign tetrahedron and hexahedron meshes simultaneously in complex geometry using the partition tools. And finally, we restrain the model with the powerful bolt connectors and finish construction with couplings and connector elements. Now, what you're seeing here is the pretension step on the bolts. So there are spring connectors between the flanges to mimic a gasket in between. So we are seeing the stress because we are tightening them or preloading them in the downward direction. Now, I threw this one in here too because I really like this, but connectors can also be used for simple and for very complex things like a Newton's cradle here. So we can get very complicated in our connectors. In scenario creation, we will create simulation steps, contacts, loads, and outputs. So now that we have a fully functional finite element model, we will launch the mechanical scenario creation app. We can see that there are many different solver and step types available to us down at the bottom here. But we're going to begin with a simple nonlinear static step and name it preload. Now, contact of all these bodies is a breeze. With the two clicks, we can assign a frictionless sliding contact between all components using the famous general contact algorithm from ABAQUS. Normally in SOLIDWORKS, you have to do a lot, or should I say, do all the contacts manually for, let's say, this bearing shown here on the screen. So using the general contact option, it does it all in just a few clicks. So all the interactions of the rollers and the bearing races are done quickly using the general contact tool. So a big time saver in setting up your connections with this general contact tool. So let's begin adding boundary conditions. A symmetry or strain is added to the cut face of the model to account for the missing material. A slider will be assigned on the back face to represent the mating components. So since 3DEXPERIENCE allows for multi-step analysis, we can add the second step to account for the boom load. And then the feature manager helps us to keep track of what loads and boundary conditions are applied in each step. So let's swap back to our first step and assign the bolt torque of 30 Newton meters here. And a bolt restraint is added to the second step to keep the preload applied. And then finally, we will add a 50,000 Newton load to the reference node we created earlier. And all that's left is to simulate. So the structural mechanics engineer role allows for 8 cores of cloud or local compute, with the option to increase the horsepower up to 144 cores. And as of today, you can actually choose up to 192 cores instead of just 144. So to solve something like this car crash here, which is very resource intensive if you're going to solve this locally on your machine, you can make use of solving on the cloud instead, which frees up your PC and will solve faster with more cores being used on the cloud. So to summarize, in scenario creation, we started by defining a static analysis from many other analysis types available. A multi-step workflow was employed to accurately account for the bolt preloads. After the preload is applied, the boom load was added to the connectors boom system we made earlier. And then finally, symmetry restraints and the powerful two-click general contact was used to quickly and accurately account for part interactions. So let's next see what results are able to get out of the analysis. So we'll now switch to showing the full model results from our symmetry method. And in our plot, we'll switch the step to the boom load. And then from there, we can click on the results at specific time to see results at that time. And then lastly, of course, we can animate the results. So what is the displacement of the end of the boom arm? So from the node set we created off of the force load, we can now make an XY plot of the displacement versus time. We can see plastic strain in our results, which is permanently deformed area with this loading. So let's plot the approximate max plastic strain versus time. Comparing it against the displacement plot, we see it doesn't start yielding until the arm starts to deform near around 5 millimeters. After that point, both the arm and the plastic strain rise faster. Unfortunately, the model indicates plastic strain in the analysis. So this means that area of the model is, of course, yielding. So armed with this information, we can make some edits to the design to increase the rigidity of the model. So the next step is collaboration between the designer and the analyst. The design engineer is tasked with changing the design on the main boom assembly. For this purpose, the 3DEXPERIENCE provides a platform with built-in collaboration tools to help designers, analysts, and everyone else in the organization work concurrently. So let's take a look at how it works. First, we log into our dashboard for the project. Opening the geometry in 3D Markup app lets me add 3D notes and annotations to the model and save them as tasks and change actions. Once the markup is made and the change in action is created, we assign the action to a user with the Collaborative Tasks app. In this case, I'd like my colleague Robert to change the model. We can attach the markup and the 3D model directly to the task, so Robert doesn't have to go looking for the correct files. So Robert receives a notification and opens it. Inside, he can see the notes we created, as well as the attached files for simulation. So all he has to do is open the assembly in SOLIDWORKS and make the needed CAD changes. So the design change is simple. We want to make the top ring a little bit thicker to better reduce the heavy boom load. So using the familiar CAD tools, the change is quick, and Robert is able to simply save the updated geometry back to the collaborative space on the platform. So with the model open in 3DEXPERIENCE platform, we can grab the most recent version of the geometry with a refresh of the PLM system. So all we have to do from the simulation perspective is to update the model. So this will update the abstraction shape we created and remesh the model according to our previously used parameters. Once complete, all that is left is to rerun the study on the cloud. So with updated results, we can see that the displacement is less than before. In addition, there is zero plastic strain present in the model. So this means our design is no longer yielding, and the subassembly has the green light to move forward through the design process. So this concludes today's webinar. Thank you everyone for attending the webinar today. If you have any questions, feel free to put them into the chat now. Also, feel free to email me at the email address shown on the screen here. If you have any technical questions, let's say you're watching this on a pre-recorded YouTube video, right? Feel free to email me at that email address if you do have any questions even there. So I'll go ahead and check here for any questions. Seeing any questions come in. I do see yeah, I'm not seeing any questions coming in here, so I guess that's it. Well, thank you everyone for attending the webinar, but that is all for today. Thank you so much.